In the previous video, we looked at deriving the first of the Pythagorean identities, that the sine of theta squared plus the cosine of theta squared is equal to 1. And we're able to find this formula by looking at the unit circle, where after graphing a point here and looking at the angle, we know that the x value is the cosine of theta, that's this length. The y value is the sine of theta, the vertical length here. And since this is on the unit circle, the radius of the circle, the hypotenuse of this triangle, is equal to 1. And from this right triangle, we can use the Pythagorean theorem to essentially derive this identity here. And this identity shows up in many different places and can be incredibly useful to know. Now, from this identity, there are actually two more identities involving the other four trig functions: the tangent, the cotangent, the secant, and the cosecant. So let's make a little bit of room and derive those other two identities. And we will start with this first identity. And so let me rewrite it. And remember that when we have the sine of theta squared, the convention is to write the square before the angle, but these mean the same thing. So we have the sine of theta squared plus the cosine of theta squared is equal to 1. And to find the next identity, we will divide every term here by, let's say, the sine of theta squared. And by doing so, we will find our second identity. Since sine squared of theta over sine squared of theta, this is just 1. Something divided by itself is always 1. This right here is the cotangent of theta squared, and this right here is the cosecant of theta squared. Since remember that with the other trig definitions, we know that the tangent of theta, this is equal to the sine of theta over the cosine of theta. The cotangent is just the reciprocal of this, the cosine over the sine, which we see here. The secant of theta is related to the cosine. It's the reciprocal of the cosine function, and the cosecant of theta is the reciprocal of the sine function. And we see the cosecant here since we had 1 over the sine of theta squared, so this would be equal to the cosecant of theta squared. And tangent and cotangent are fairly straightforward to remember since they are just reciprocals of each other. You just flip the fraction. Cosecant and secant can be a little bit harder to remember, but the way that I've always remembered it is that you would think cosine and cosecant go together, but they don't. And so I remember that it's the opposite of what you would normally think. So the cosecant you would think would go with the cosine, but it in fact goes with the opposite. It goes with the sine, and it's just the reciprocal of the sine function. So for instance, we can also rewrite this as the sine of theta is 1 over the cosecant of theta. These are equivalent statements. So this statement, 1 plus the cotangent of theta squared is equal to the cosecant of theta squared. This is the second of the Pythagorean identities, and we will find the last one in a similar method. We will again start with the sine of theta squared plus the cosine of theta squared is equal to 1. But instead of dividing by the sine squared of theta, we will divide everything by the cosine squared of theta. And this will simplify to a statement involving the other two functions, the tangent and the secant function. And we can see we have sine over cosine, and they're both squared. But sine over cosine is just tangent. So this right here is the tangent squared of theta. This is just 1. Something divided by itself is always 1. And here we have 1 over the cosine, but that's the secant function, and it's squared. So this is the secant squared of theta, giving us our final of the three Pythagorean identities involving the trig functions. And if you want to make more sense of how, let's say, the sine of theta squared over the cosine of theta squared is equal to the tangent of theta squared, it essentially just uses exponent properties. Since this right here, let me just make a little bit of room. This can really be written as the sine of theta over the cosine of theta squared. Since when you're squaring a fraction, the numerator and the denominator are squared. So these are equivalent, and then just replacing this with the tangent of theta. And we use similar ideas for each of these other simplifications. So these three Pythagorean identities will be used in many different applications.